Hi everyone. So welcome back to my class. Uh, as I have promised that I'm going to start communication system. Okay, so we are doing analog circuit. In parallel now we will be doing communication system. So communication system is one of the very important subject for electronics and communication branch student as well as who will be appearing in electronics branch, right? And this subject will also help you to prepare the gate paper like data science and artificial intelligence as well, because the mathematical content what we need to understand the communication system is like random variable, random process, and so on and so forth, right? So basically I'm going to talk about communication system under three umbrella, under three important topics. One will be the basics of communication system, what we need basically to understand communication system. That will come under basics. Okay, so let me start the subject called communication system. Okay, communication system. So communication system is basically in gate examination. If you see the weightage of this subject is around 12 marks, 12 marks. And nobody guarantees that you're going to score complete marks from this subject. But I guarantee, from the very beginning, I guarantee that you will be able to score complete marks from this subject. Okay. Because the way I have analyzed the PYQ as well as you can say the content and the content what we are going to refer, I mean the books we are going to refer, they are amazing, right? So communication system will be asked for 12 marks. Okay, so we are going to study communication system under three basic topics, right? So first will be the basics, right? So first we will cover the basics. Okay, you can say the prerequisite to understand communication system. And I think everybody is familiar with the communication, the word communication. What does basically it stands for, right? So communication basically tells you about transmitting some sort of a message from one place to another place, right? Like you want to exchange kind of information. Okay, suppose you want to send your message signal from your end to your friend. Okay, so you always send a message in terms of in the form of text, voice, video, and so on and so forth. And this communication happens uh, most of the time in our daily life, right? So 90% communication, if you look at, that happens as a human communication, right? So communication basically happens, animal cannot communicate to each other, right, by speaking or something that we know, but human can do. So 90% communication on the earth, you will see, will be involving humans, right? So and nowadays we interact with the machine as well, and machine also interact. So hi, Dibyani, yeah. So this is going to be the first session, right? So you have to attend this session so that you can get started and your phobia of communication will be over now, right? So the first is going to be the basics. I will be covering the basics. Next will be the analog communication, right? So there are two kind of communication system that we are going to look at. One will be the analog communication and second is going to be the digital communication. Okay, digital communication. Okay, analog communication as well as the digital communication, right? So there are three parts basically. One is very important, the basics. If you're not good at basics, right, you cannot understand any other like analog as well as digital, right? So whenever you look everything around you, right, everything is what your nature is analog only, right? And there are certain advantages of using digital communication. Those advantages and all those things we will discuss later, but we need to understand first of all what we are going to study under this subject, right? So basics, analog communication and digital communication, right? So nowadays this is also important, this is also important in the gate examination per se, right? You will find question from digital communication as well as analog communication. The more weightage we give to digital communication, right? Okay, so what are the basics we need? This you can say is just like a prerequisite, right? This is a prerequisite. Okay. Prerequisite. Okay, so in communication system, if suppose I consider myself as an engineer, right, the communication engineer, So we need to focus only on two resources, okay, two things, okay. So what are the resources of communication system, okay, that you have to always keep in mind. They are bandwidth as well as the power, okay. So in entire communication system, I will be discussing about power as well as the bandwidth, right? Power bandwidth, okay. We'll see, okay, this communication system, okay, there will be some sort of modulation schemes, okay, modulation techniques, okay. So some modulation technique will be power hungry. You can say they will take more power, right, to transmit masses from one end to another end. And some modulation schemes will consider more bandwidth, you can say, right. So as an communication engineer, we will try to trade off between the two, right. So you have to start with this, right. So there are two resources, basically two resources, okay, two resources of the communication system. They are bandwidth and the power, okay. You will find that in analog circuit, in analog communication as well as in the digital communication, in both the communication system, guys, I will be computing power, I will be computing bandwidth, right. In case of digital communication, this bandwidth is considered as a bit rate, okay. अभी यहाँ पर आपको bandwidth समझ में आ रहा है, ठीक है. ये analog communication में this word we will be using bandwidth, right. But in digital communication, this bandwidth will be considered as bit rate, okay, the bit per second, okay, bit per second. So you have to remember these two things we will be computing all the way as we move to toward the end of the course, right. So prerequisite is what? Prerequisite is one of the very important subject only, that is signal and system. Signal and system. Why signal and system? Because after all, you will be transmitting signal only, right. So, and you have to worry about bandwidth, you have to worry about power, right. So bandwidth is related with the frequency, right. So if you want to know, suppose signal is there and signal is given in time domain, right. So if you want to know the content of the signal, I mean frequency content of the signal, right, then only you can decide the bandwidth, okay. Suppose you have to send some signal, so you need to have some channel as well, right. So there will be three component: transmitter, channel, as well as receiver, okay. So if you want to decide what will be the bandwidth of the channel, okay, how many signal you can transmit through that channel, right. So before you decide the bandwidth of the channel, you need to know the frequency content of the signal, right. अब कैसे frequency content of the signal find करेंगे? So we need to know the Fourier transform, right, because we can, you know, we can make transformation from time domain to frequency domain with the help of one important tool, that is Fourier transform, right. So Fourier transform is very important you know, aspect that you need to know, and we need to talk about energy, power, so many things, right. So we need to understand what will be the energy of the signal, how to compute energy of the signal, so on and so forth, right. So this is the very basic subject, okay, that is signal and system. You should know. If you don't know, still I will be helping you in the first session how to, you know, what are the important topics that I will be giving you recap. तो आपको कोई दिक्कत नहीं आएगी. And the reference book which we are going to follow, right? The reference book which I am going to follow is I'm just going to list them out. You don't have to refer each and every page. Just after the session you can take a look, right? अच्छा ये चीज है, ठीक है. At least you can take a look in you know, on given examples, right? Because sometimes what happens in the gate examination, they directly take example from those books, right? The very first book is Proakis, okay, Communication System Engineering. Okay, this book I have shared also in the group, Communication System Engineering by Proakis. Okay. And second one is BP Lathi. Professor Lathi has written, BP Lathi. And third one is these are the books I'm listing down, right? Simon Haykins. Okay. And the fourth one is Thomas M. Cover. Okay, Thomas M. Cover. Okay, okay. This book is meant for information theory. Information theory. So you don't have to worry about these many books I have told you guys, right? Just wait and watch. My content will be enough. I will be giving you the assignment from these books, right? So you will be able to solve all the questions, don't worry, okay, according to gate, right? These are the books which I will be referring. Okay. One more book is there, that very easy book, that is known as Psalm series, right? Psalm series. Okay. So these are the books, guys. In some of the books, you will find that author has done all the analysis in omega domain. Okay, whenever they find the Fourier transform, right? So they do Fourier transform in omega domain, also in frequency domain, F domain, right? So you don't have to worry about, because omega is related with frequency F, right? Like this, omega equal to 2 pi F, right? But this is very important book, okay, that I have seen, because nowadays questions are being asked in communication system from information theory most of the time, because after all, information is everything, right? Communication system we are studying just because of information we have, right? In the form of text, video, music, whatever you say, right? Information, after all, we have to send information, right, in some of the form. Okay, so this is very important. Okay, fine. So what are the things I will be covering now? This is very important. Okay, you have to watch these session at very high speed, right? Okay, so please keep in mind. So basics, what you need, as I told you, if you are communication engineer, right? So where you have to focus, power bandwidth, okay? Power bandwidth, guys. You should know how to compute power of any modulation system. You should know how to compute bandwidth of any modulation system. Just say, if I talk about amplitude modulation system, right? Amplitude modulation, AM modulation, right? उसका क्या bandwidth होता है? तो you will say 2 times FM. I will discuss all these things, just I am giving you, right? So why you are talking about this? Because that these are the basic resources of communication system, right? These are the basic resources. The basic resources, okay, of communication system. Any communication system, be it analog or digital, right, is going to be what? Power and the bandwidth. Remember, right? The bandwidth and the power. Okay. In digital communication, we will call this bandwidth as bit rate. Okay, bit rate. Okay, so these words you will come to know. Okay, bits per second, as well as you will come to know baud rate. Baud rate, bit rate, baud rate. Okay, bit rate, baud rate. And signal. Signal is one of the very important, mathematical function, you can say. The signal will be of different kind, right? You have seen continuous time signal, you have seen discrete time signal, you have seen analog signal, digital signal, right? Okay, so basically signal will be of two kind. Okay, one will be random signal, one will be deterministic signal. Random signals are those signals which cannot be expressed mathematically, right? Though we will be treating lot of math, okay, with random signal as well, okay, with the help of probability, but आपको समझना है कि math, if any signal you are not able to express mathematically, they are not deterministic. Deterministic signals are those signals like sine omega t, cos omega t, if you are able to write them. Okay, like noise is a random signal, right? Music, you say music, if you play, so it has very different kind of waveform, you can say, with respect to time. If you speak something, okay, these are what? Random signals, right? Okay, they are not deterministic signal. Your voice, whatever you see, right? So this is very important, you have to keep in mind, random as well as deterministic, right? So the very first topic that I will be talking about here is under basics. First, I will talk about how to compute energy of the signal and the power. So you can say definition of energy and power. Energy and power signal. Right? So I think you should know what is energy signal, what is power signal. Okay, energy signal as well as the power signal, right? So energy signals are those signal. Okay, let me define as we move ahead, as I will mention the topic, I will be defining these. Okay, so energy of the signal, suppose signal is given, I think everybody is familiar with the signal, right? Signal is nothing but information bearing. Okay, if any signal is there, if it contains some information, you can say that is a signal. Any mathematical function which contains information, which conveys some information. Okay, suppose any signal is given and it does not convey any information, right? So that is not a signal, right? Okay. Okay. I think everybody faces this, every day, everybody face kind of a signal, right? Traffic control signal, you can say, different sort of, right? So suppose I send a message to you, and if that message does not convey any information to you, so that is not a signal, right? What we do every day in the form of text. Okay. So signal I'm not gonna define. Suppose you consider signal xt, which is a function of one variable time t, right? So if you want to find the energy of the signal, right? So energy of the signal you can find out, okay, with the help of integral. Okay, as far as this signal is concerned, this is a continuous time signal, guys. Continuous time signal. So continuous time signal is, so you have to take the mod of this xt. Okay, first take the mod. Okay, then square of this. Okay, what you have to do, first take the mod of xt, then square. See, if xt is real, so this you don't have to take mod and all, right? But if the xt is what, complex, right, then you can take mod, so that mod will manage everything, right? So xt mod square, then you can do you can integrate this from minus infinity to infinity dt, right? This is the energy of the signal, right? And when you can say any signal is the energy signal, okay, when you can say any signal is the energy type, okay, and the power type. See, if you are trying to compute energy of the signal, okay, so that energy should be finite. Okay, if the energy is finite, you can say it is less than infinity. If the energy is finite, then you can say that that is an energy type signal. Okay, if the energy is finite, means that is an energy type signal. If the power is finite, then you will compute power of the signal. Okay, if the power is finite, then you can say power signal. Okay, so these, they should be finite. Okay, finite. Okay, so please keep this in mind, guys. Okay, if the energy is finite, then you will say energy signal, otherwise that is not the energy signal. Okay, fine. So let us take one example here. Let us compute the, okay, let's take example. You can say xt is given as e raised to power minus t ut. Okay, e raised to power minus t ut. Okay, so this is what you can find the energy of this guy, xt equal to, I think everybody knows the shortcut as well, but I will tell you here. You know, ut starts from where? Ut starts from, ut is 1 for t greater than 0 and 0 for t less than 0. Okay, so this integral will start from 0 to infinity e raised to power minus t whole square dt. Since this xt is real signal, okay, this guy is real. Okay, see, whenever this kind of question comes now, we don't care about whether it is real or imaginary or whatever, right? We need to care it, guys. Okay, in the book you will find xt is real valued signal. Okay, real valued signal means it, there is no complex, there is no imaginary component present. Okay, remember. Okay, there is no imaginary terms like j iota kind of thing. Okay, so if you 0 to infinity e raised to power minus 2t, okay, minus 2t dt, I think you can integrate this guy, so it will be minus 2, right, e raised to power minus 2t, limit 0 to infinity. So this guy will give you 1 by 2 as a energy. Okay, so I think in a computing energy is very simple. Okay, computing energy is very simple. How to compute energy of the signal? So you can say this is an energy signal because energy is coming out to be finite. Okay, this is an energy signal. Okay, okay, this is a energy signal. Okay, so there are many definitions of energy. Finite duration signals are known as energy signal. Okay, finite duration signals are known as okay, okay, finite duration signals are known as energy signal. Okay, or as t tending to infinity, okay, the signal should decay. Okay, signal should become 0, then you can say that is the energy signal, right? Fine. So I believe this is fine for everyone, right? So you can say that for signal xt, right, if energy of the signal ext, right, is finite, okay, energy of signal is finite, then you can say that xt is termed as what? Then xt is termed as energy signal. Okay, it is not a power signal, it will be an energy signal. So you can say that ex should be what? Less than infinity. Yeah. So you should know energy signal and what is power signal, right? What is the power of the signal, that you have to understand. So power of the signal. Power of the signal. I think everybody is familiar with this. Okay. Those who are not familiar, please watch my sessions, right? Okay, watch my sessions and you can always get in touch with me. So because I will be talking about bandwidth, power, okay, and I will be talking about taking Fourier transform and all, right, of the signal, right? So you have to understand. So power of the signal is nothing but, suppose xt, we call it xt is a power signal, right? How we say that xt is a power signal, that you should know. xt is a power signal, it means the power is gonna be finite. अगर power finite नहीं है किसी भी signal में, अगर power finite नहीं है, then that is not a power signal. Okay, power signal means the power should be finite. Okay, understood? So we need to take again the mod of xt square, and then we need to integrate from t by 2 to t by 2. Okay, and then we need to average, right? So we always try to compute power, that is average power we always compute, you know. And I think everybody might have heard about periodic signal. Okay, periodic signal, which is everlasting signal. Okay, from minus infinity to infinity, the periodic signal which repeats after certain time interval, right? You can say after some time t, after some, you can say small time t, capital T, that signal will get repeated. Okay, so that is known as periodic signal, right? And that capital T is known as fundamental period, we call it, right? So you have to understand that we always compute average power. You can see in network theory we always compute average power. Okay, all those things. So this is the average power. Okay, we, and integration interval, you see, from minus t by 2 to t by 2. See, minus t by 2 to t by 2. Okay, we consider for our simplicity. Okay, you can also write from 0 to t, no problem. 0 to t also you can integrate. So if you add, what is the interval here, that is t, right? So we are averaging, and then we will apply the limit here, limit t tending to infinity, right? Limit t tending to infinity. This is nothing but a power signal. Okay? Power of the signal. This is nothing but power of the signal. We call it average power. Okay, so remember guys, average power as well as the energy. Okay, so I will suggest that you take a look, okay, on in Proakis chapter. Okay, and you will find that you, at least you can make a short note quickly. Just look what are the important points, you can note down. Okay, because sometimes in the gate examination what happens, they give you question from there directly. Those statements are very important, right? Okay, statements are very important. So signal and system, sometimes they take concept from Proakis and they give in the gate exam. So if you know already everything, then it's good, right? Now fine. So I think power signal is fine. Okay, so if the energy is if suppose any signal is a power signal, right? If any signal is a power signal, or you can say if any signal is an energy signal, so what you can comment on here is, then the power is going to be what? Then power will be 0. Okay, then power will be 0. Okay, you don't have to compute, guys. If any signal is a energy signal, let me comment here. Okay, it is very important statement. If any signal is a energy signal, right? If any signal is an energy signal, right, then you can say that the power is going to be 0. Power is going to be 0. How? You see, let us recall the definition of power. देखो power क्या होता है? Average power is going to be equal to minus t by 2 to t by 2 x of t whole square dt, and average over t, right? Limit t tending to infinity. So you can write this as, see, this is nothing but a energy. Okay, this is nothing but a energy, right? Energy, you can say energy over one period, right? Okay, this is nothing but a energy of over one period. One period we are trying to find energy, and if this signal is an energy signal, you can say, right? So what will happen? Energy, right? You say this is the energy signal, so we'll get energy upon t. Okay, energy upon t. And if t tending to infinity, then what will happen? What will be the power here, right? Suppose E is finite. Okay, E is finite, then the power is going to be 0, right? Understand? So please remember this. If signal is an energy signal, okay, so you can blindly write power is gonna be 0. Power is gonna be 0. Okay. It is very important fact that you have to remember. Okay. It is very important fact. If the energy is, if the signal is an energy signal, then you can say power is gonna be 0. Okay. So if the signal is power signal, okay, if the signal is a power signal, okay, the signal is the power signal, okay, then power is going to be what? Then power will be, you can say power will be finite. Okay, then the power is finite, remember. Okay, if any signal is a power signal, then you can say power will be finite. So in communication system, we always talk about power signal, right? We don't talk about energy of the signal. The reason, what is the reason behind that, we will see very soon, right? Because you will use the carrier, okay, to transmit. Okay, you will use carrier to transmit your message signal, right? Okay, while discussing modulation, we will take one carrier signal, right? Carrier signal will be the deterministic signal, you can say. That will be written like AC cos omega t plus phi. Carrier signal is a deterministic signal, guys, but your voice is not a deterministic signal. That you have to understand, right? So carrier signal is a deterministic signal. You can say AC cos omega ct plus phi. Carrier signal we will use. Carrier signal will be having high frequency, okay, high frequency compared to your message signal frequency, right? So carrier signal will be high frequency. It will be having amplitude of the carrier, the frequency of the carrier, as well as the phase of the carrier. Depending upon their variation, amplitude variation, frequency variation, phase variation, we will define different kind of modulation scheme, modulation technique, and we will see what is the meaning of modulation, why do we need to do modulation, okay, and how we can relate, those property what we have learnt in Fourier transform, like modulation property, right? I think everybody might have understood, might have seen in somewhere down the line the modulation property of the signal, right? So all those property we will use. If the signal is a power signal, please remember, if the signal is a power signal, okay, so the energy is going to be infinity. Energy will be infinite. Okay, energy will be infinite. Please remember, okay. If the, okay, this is very important to remember. Energy of a power signal is going to be infinite. So blindly you can say that if, okay, let me take one example. Suppose you are finding, suppose we have got ut, right? Suppose you have got xt equal to ut, and ut is nothing but unit step signal, okay, which is shown like this, okay. It is an approximated signal ut, right? Okay, you can say that, let us define, okay, like it will be 1 for t greater than 0. Make sure that this is a strict inequality, right? T greater than 0, it should not be t greater than or equal to 0, right? Because at t equal to 0, this u of t is discontinuous, guys. This u of t is discontinuous, right? Okay, and the value of u at t equal to 0 is going to be half. You have to understand, this will be half at t equal to 0, and 0 for t less than 0, right? How do we determine this t equal to 0? You can say that u of 0 is going to be u of 0 plus u of 0 minus upon 2, right? Whenever there is a discontinuity, so we always take the value, okay, less than 0 as well as, okay, and then we divide by 2. We take the average, you can see. Okay, this is the approximation we do. So guys, this is the xt, basically we know, right? Xt. Now how to find powers? Power is nothing but power. See, we cannot define here the time period, right? You see, u of t has infinite time period, right? You see, it is constant throughout, right? So you can say the average power, this is the average power. We always compute average power, guys, remember. So you can say that it will be starting from 0 to t, okay. You can say 0 to t by 2, right? 0 to t by 2, okay, and this is 1 by t, this is 1 dt, right, and limit t tending to infinity. Okay, so limit t tending to infinity means what? See? what will happen here is that you can say this will be coming out to limit t tending to infinity 1 by t, okay, because we are integrating from where to where, minus t by 2 you can say to t by 2, right? So this is nothing but t by 2, t gone, so 1 by 2 will be the power, right? You can say 1 by 2, okay, 1 by 2 is going to be the power. So I think this is clear, right? So if you take like it is starting from 0 onwards, right? So 0 to t by 2, or you can take full period, right? Because see, what you can do here is you can say that let us not take t by 2, okay, because we are going from, let me apply the actual definition again. Okay. What we can do here is we can say that average power xt is going to be limit t tending to infinity 1 by t, and this is nothing but from 0 to t you can write, okay, from 0 to capital T, okay, that is one period, over one period we are doing, and then xt whole square dt. So now you can say that xt is going to be limit t tending to infinity 1 by t, okay, 0 to t. We don't know the time period of ut, so you can say 1 square dt, right? So here you will get tt, that is 1. You see here the power is coming out to be finite, okay, the power is coming out to be finite. Earlier we have taken t by 2, right? Okay, so power, certainly power will be 1 by, you can say 1 by 2, right? But here the power is going to be what, 1, okay? So this u of t you can say is a power signal, right? Power signal, okay, it is not the energy signal, and if you try to compute energy of the signal then it will be infinite, okay? ये याद रखना. So any signal is there, if it is a power signal, so okay, power signal, so it has power finite, okay, and energy infinite. And if it is a energy signal, okay, so it should have finite energy as well as zero power. You see the magic here, right? I think now it is clear, okay? So energy and power are one of the very important aspects. You should know the periodic signal as well, because all periodic signals are power signals. This statement is very important, guys. All power signals are periodic, all periodic signals are power signals, okay? This statement you can note down. All periodic signals are power signals, okay? The periodic signal. And why we are discussing periodic signal? Because after all we will be using carrier, okay, the periodic signal, carrier signal, right? Okay, like AC cos omega ct plus phi. If any continuous sinusoidal is given, so you can blindly say that yeah, it is a periodic signal, right? You don't have to worry about that. Directly you can say any sinusoidal signal is given, you can say that that is a periodic signal, okay? So periodic signal is what? The signal which follows this property, xt plus capital T should be equal to xt, okay? That this is the definition you can say. If xt is a periodic signal, okay, if xt is a periodic signal, right? If xt is a periodic signal, then xt plus t equal to xt, right? xt plus t equal to xt, okay, where this t is going to be what, okay, t is going to be what, t will be the you can say smallest time period, right? We call it smallest time period, okay, smallest time period. Time period should be small, okay, or you can say fundamental period also, we call fundamental period. You can also say that time period, right? You can also say that xt plus k times capital T will be equal to xt only, right? Okay, and here you will say t 2t, okay, this will give you what, t 2t 3t 4t and so on and so forth, right? Where k is just an integer, okay, we are considering k, okay? So what will happen here is that the smallest t is going to be the fundamental period, okay? Smallest Okay, so this k is nothing but k belongs to, you can say, the integer, right? Integer multiple of time. Okay, so sometimes we call it harmonics as well. I think all periodic signals you can find out the you can say Fourier series of periodic signal, right? Fourier series. Okay, periodic signal we always compute Fourier series. Aperiodic signal we compute Fourier transform. ये आपको याद रखना है, ठीक है? So if a signal is periodic signals, we go for Fourier series, right? And if a signal is aperiodic signal, we go for Fourier transform. Okay? So all periodic signals are power signals. Remember, all periodic signals are power signals. So all periodic signals are power signal, guys. Please remember this. This statement is very, very important statement that I am telling you, right? Okay, and it will be having fundamental time period. It will be having fundamental frequency as well. So I hope everybody knows how to compute frequency as well as the power. Fundamental frequency as well as the fundamental time period, right? So whenever the any signal is there, it is a periodic signal. So how to compute power of the signal? So power of the signal you can compute directly just by finding the energy. You can say energy in the window signal, right? Window of capital T upon capital T. Right? What is this window? I'm telling you. Window means in one time period you just find out the energy and then divide by capital T. That will be the power signal. Okay, I mean that will be the power of that signal, right? So it is very simple. Suppose in the exam they will give you the power, periodic signal, and they will ask you to compute the power of that. Okay, and you should also know that if any signal is shifted by some amount, right? So shifting does not affect energy as well as the power, right? Okay. So you have to simply compute energy of that you can say within that window and divide by the time period T. Okay, that will give you the power. I think you guys can compute always, right? So let me take one very important example, because this we will be using throughout the communication system, in fact analog communication as well as digital. We will take here xt equal to AC cos 2 pi fct plus phi. Okay, you can also write this as AC cos omega ct plus phi. So needless to worry about, because see here omega c is what, 2 pi fc, and what we are saying here is that this AC is nothing but the amplitude of this signal. Okay, and fc is nothing but the carrier frequency, right? तो ये सिग्नल हम लोग यूज करेंगे थ्रू आउट. ओके, याद रखना, इसलिए मैं आपको बता रहा हूं. तो दिस इज आल्सो नोन एज कैरियर सिग्नल, राइट? रिमेंबर, carrier signal, okay, which will carry the information, carrier signal. Okay, so AC cos omega ct. Suppose I want to find the power of this signal, and you can blindly say that this signal is a periodic signal. Okay, AC cos omega ct plus phi is going to be the periodic signal. अगर मान लो इसका तुम्हें पावर निकालना है, if you want to find the power, so you can directly find out the power. You should know the RMS value of this cos omega ct or sin omega ct. I think everybody knows what is the RMS value of this. Okay, so RMS value is nothing but, right, directly you can compute. Root mean square is going to be AC by root 2, and what is power? Power is nothing but RMS square. So whenever sine, cos, whatever is given, and if you want to find the power, so find out the RMS value and take the square of that, right? So that will give you the power. So it will be AC square by 2. This is the power of, okay, cos omega ct. So you can also use integral. Okay, you can also use integral and you can compute power. AC square by 2 you will get, but I'm not showing that. Okay, I'm not going to show you. Okay, and you see guys, this phase is not going to affect your power, right? This does not play any role. Remember, if you want to compute power, okay, irrespective of the phase, right? Because that phase, from where we are getting that phase, if there is a time shift in the time domain, so there will be a phase shift in the frequency domain. ये भी एक स्टेटमेंट याद रखना, ठीक है. तो पावर कैलकुलेट करना इज वेरी इंपॉर्टेंट फॉर कोसाइन एंड साइन, ओके, and you can directly integrate as well, right? Okay, so after discussing energy, power and periodic signal and so on and so forth, we will discuss the frequency domain representation, right? Frequency domain representation, okay, representation, okay. देखो, under frequency domain representation, what I am going to discuss is I will tell you the Fourier series, okay, Fourier transform, right? Because these are very important tool, okay, to find the frequency component of the time domain signal. क्योंकि आपको at the end of the day you have to decide the bandwidth of the channel, okay, through which you will transmit signal, okay. अगर आप सिग्नल को ट्रांसमिट करना चाहते हैं, राइट, तो आपको बैंडविड्थ डिसाइड करना पड़ेगा अपने चैनल की. अब चैनल की बैंडविड्थ कितनी होनी चाहिए, हाउ मेनी सिग्नल यू आर ट्रांसमिटिंग, राइट, एट द सेम टाइम यू कैन से, राइट. तो उसको हम लोग मल्टीप्लेक्सिंग भी बोलेंगे, कितने सिग्नल आप साथ में भेज रहे हो साइमल्टेनियसली इफ यू आर ट्रांसमिटिंग द सिग्नल, ओके. So if you want to decide the bandwidth of the channel, so you need to know the bandwidth of the signal as well, right? Okay, each signal, how much bandwidth each signal is, requiring, or you can say need, okay. So how to find that frequency bandwidth, okay. Bandwidth, you need to, if you want to compute bandwidth, you need to know the frequency content. And how to find the frequency content? With the help of Fourier transform, right? So if the signal is periodic signal, then you need to go for Fourier series. If the signal is aperiodic signal, you need to go for Fourier transform. बस यही सारी चीजें हैं जो आपको आनी चाहिए. मैंने आपको बता दिया है सिंस बिगनिंग. द कम्युनिकेशन सिस्टम के दो ही रिसोर्सेस हैं पूरे कम्युनिकेशन में. आप देखो भी जितने भी गेट में क्वेश्चन आए हैं आज तक, ठीक है, जितने भी गेट में क्वेश्चन आए हैं, दे ऑलवेज टॉक अबाउट पावर, दे ऑलवेज टॉक अबाउट बैंडविड्थ. जब हम digital communication, when we will discuss, there we talk about probability of error and all. What is the, why we discuss probability of error and all, you will come to know, right? ठीक है, तो आप देखोगे बैंडविड्थ आता है, पावर आता है, रेशियो ऑफ, ओके, डिफरेंट बैंड्स आर देयर, सो मेनी थिंग्स, राइट. बिट रेट वी डिस्कस, ओके, ठीक है. तो फ्रीक्वेंसी रिप्रेजेंटेशन, राइट, फ्रीक्वेंसी रिप्रेजेंटेशन, इट इज वन ऑफ द फंडामेंटल टूल फॉर कम्युनिकेशन. इट इज अ, and say fundamental tool for communication, right? Communication system. So be ready guys, I will be sharing assignment from second chapter, right? So I will show you the assignment of Proakis as well. You can take a look. Second chapter you have to start with, right? First chapter is story, history behind communication. Those things are not needed at all, you know, because 90% human communication is there, right? We know we have to interact with people, we have to send messages to people, right? Suppose I'm in India, my friend is in US, I want to interact with, so we need to have communication. So in order to establish communication, we need bandwidth. आप इंटरनेट यूज करते हो तो ये क्या है, बैंडविड्थ तो है ना. यू कंज्यूम बैंडविड्थ एवरी डे, राइट. कितने बिट रेट में, एमबीपीएस, पीपल कॉल इट 100 एमबीपीएस, है ना. तो 100 एमबीपीएस क्या, ये बिट रेट है ना, मेगा बिट पर सेकेंड, राइट. वी वांट 100 एमबीपीएस बट वी डोंट हैव टू डू एनीथिंग, है ना. तो व्हाट वी आर डूइंग, वी आर कंज्यूमिंग. अब देखो वीडियो, जब आप वीडियो इंटरेक्शन करते हो तो आपका डेटा जल्दी उड़ जाता है, राइट. इट रन्स अवे, राइट, लाइक 2 GB डेटा, ओके, व्हाट यू रिचार्ज ईच मंथ फ्रॉम जियो, राइट. तो 2 GB, जैसे इफ यू स्टार्ट टॉकिंग विद योर फ्रेंड फॉर 1 hour, so your data gets, understand. So you need to understand, okay. So after we are discussing about 5G, 6G, 4G, ये जो, okay, तो ये सब क्या है, communication system है, right? Okay, that you have to understand. So frequency representation, why we want to study, because it is one of the fundamental tool, or basically we have to talk about, we have to find the spectrum, and spectrum, there will be magnitude spectrum as well as the phase spectrum, right. This spectrum will give us the frequency content, right. This spectrum is going to give you the frequency content, right. So there will be two sort of spectrum which you will find, okay, understood. Spectrum, Understood? You will see two sort of things. You can get a spectrum from the Fourier series, and you can get the spectrum from Fourier transform, right? Fourier series से आपको मिलेगा, Fourier transform से मिलने वाला है. In case of Fourier series, the frequency is going to be discrete, okay, discrete in frequency. The spectrum when you will find from the Fourier series, right? From the Fourier series, suppose you are finding the Fourier series of any periodic signal, right? Why we need Fourier analysis, ये भी मैं आपको बताने वाला हूँ guys, very quickly, क्योंकि that strategy you should know, okay? Nobody knows that strategy, okay? So I will be telling you what are the strategy we follow in signal and system basically, right? If you know that strategy, your signal and system will be completely covered from this class itself, right? And you can start solving the problem, right? I will tell you. If you are trying to find the spectrum, okay, from the Fourier series, you will get spectrum will be discrete in frequency, right? It will not be continuous. And the spectrum which you will obtain from Fourier transform is going to be continuous in frequency. Continuous in frequency. ये सब छोटे छोटे points that you have to understand, right? Now the question is, why do we talk about Fourier analysis? Okay. So important strategy which we follow. Important strategy. Okay. Which we follow, okay, while studying signal and system, right? अब आप लोगों को ये नहीं पता है, आज पता चल जाएगा. Now today you will come to know what are the important strategy. आपको लगता होगा सर shortcut, sir, oh shortcut and all is different thing guys. Okay, what are the important strategy we follow? Number one, remember, we need to choose basic signals first of all. Okay, we need to choose basic signals, guys. First of all, we need to choose basic signals. What are the basic signals? Basic signals are like complex sinusoids, impulse signals, unit step signals, ramp signals. Okay, these are the basic signal, guys. Okay, these are the basic signals. So we need to choose basic signal first. Okay, if you want to analyze something, okay, if you want to get some output, okay, if you are applying, okay, you will see that one very important system, that is LTI system, linear time invariant system, right? So you have to choose basic signal always. Don't apply any complex signal. Very not complex, I mean complex in the sense here complicated, right? Complex signal you can apply happily. Complex signal I mean to say which has real part as well as the imaginary part, okay? But I'm talking about complex in the sense that which is highly complicated, right? Okay, so you choose basic signal so that you can express any arbitrary signal, so that we can express any, or express, or you can say you can decompose, we can decompose any arbitrary signal as a linear combination of basic signals. Okay, as a linear combination of basic signal. Okay, so linear combination का मतलब क्या होता है? Just take one scalar constant, multiply with the basic signal, okay, and add it. Multiply with the basic signal, add it, right? That is what the linear combination. I have taught also linear combination. What is? And the second strategy that you should know is, suppose you are applying impulse. Okay, suppose you are applying impulse to the LTI system. Okay? If you are applying delayed impulse, you can say delayed. Suppose you are applying delayed impulse. Right? If there is a delay, if you are choosing basic signal is a delayed impulse, right? So this will lead to what? Always keep in mind, this will lead to convolution. Okay, convolution. Okay. And if you're going to apply complex exponential, it will lead to Fourier analysis. याद रखना अब ये Fourier analysis, right? So if you are applying complex exponential to LTI system, okay, so that will lead to Fourier analysis. That you can see. I will show you. Here you go. Suppose you apply here. Suppose you are giving delta of t to LTI system, right? Delta of t to LTI system. Okay. So this is the LTI system. Okay. So what you will get here? You will get h of t. What you will get? H of t. Okay. We call it impulse response. What we call it? Impulse response. Okay. Like we are applying input as impulse, so we are getting kind of response which is known as impulse response, right? Now you can delay this. Now you can delay delta t, right? So if you are delaying delta t by tau, you can, some tau is there, you can delay this guy with tau. So if you're delaying here, so your impulse response will also get delayed by tau, right? Simple. Because of time invariant property, right? Because we are considering time invariant system, right? Linear time invariant system. Okay. So we can directly apply time invariant. Okay. If you are delaying input, so your response will also get delayed. Now what you can do here is you can multiply with x of t. Okay. If you are multiplying with x of t, so you should know the sampling property as well, right? You should know the sampling property. Okay. So I'm going to multiply here. You can multiply, okay, simply. So you can multiply xt here, xt, or you can say x tau. Let me multiply here with x tau. So if you're multiplying, so let me multiply in the next step. So if you're multiplying x tau means what? You are sampled, you are multiplying some value here, okay? Okay, suppose xt is there, right? Xt times delta t minus tau, right? So if you're multiplying with impulse, means this is what? This is the constant value, right? Remember, this is a constant value, okay? So that is the scalar, you can say. So here x of tau delta t minus tau, multiply here as well x of tau h t minus tau. Then what you will do? This is the sampling, okay? Now what you can do? You can take the linear combination. So it is a continuous time signal, right? Both side you will see input is continuous, output is also continuous. So you will have to integrate it, okay? You can integrate it, okay, from minus infinity to infinity. X of tau delta t minus tau, right? D tau is going to be equal to minus infinity to infinity x of tau h t minus tau d tau. So guys, can you tell me what is this? This is nothing but x of t. So any signal x of t you are able to write with the help of delayed impulse. See, x of t, you can say x of t is nothing but linear combination of delayed impulses. See, x of t is what? X of t is an arbitrary signal, any arbitrary signal, you can say any signal, right? And you are able to write them as a linear combination of delayed impulse. See, if there is an integration, means that is also linear combination, guys. Because after all, that is a continuous time signal, okay? So we are integrating. अगर discrete time signal होता तो हम वहाँ summation use करते हैं. That you have to understand. So x of t is nothing but minus infinity to infinity x of tau delta t minus tau d tau. आप ऐसा लिख सकते हो. Any signal you take xt, you can always write in terms of delayed impulses. So how we are getting this? You know, we can use the sampling property and area property. I think everybody knows this sampling and area property of impulse, continuous impulse, है ना? क्योंकि आपको पता है जहां पर where the impulse exists at t equal to tau, or you can say tau equal to t. So area under that will be xt only. So this is nothing but area under xt minus tau. ठीक है? You see, this is xt. And what is this, guys? This is okay. This by t is going to be what? This by t is going to be, see, we are writing xt as minus infinity to infinity x of tau delta t minus tau d tau. Guys, it is nothing but linear combination of delayed impulses. Linear combination of basic signal which we choose. Okay, I hope this makes sense to all. And this will lead to by t equal to minus infinity to infinity x of tau h t minus tau d tau. It is nothing but a convolution, guys. Convolution of xt and ht, or we write by t equal to xt convolve ht, right? Okay, this is nothing but a convolution integral, right, in case of time domain. So I think everybody understood this, whatever I have told you, right? So what is your basic strategy of studying signal system? You have to choose basic signal, should be able to write as a linear combination. We took delayed impulses, right? Now we will take complex sinusoids, a complex exponential you can say, or complex sinusoids, right? Complex exponential. Okay, so it is one of the elegant input, right? If you give complex exponential to LTI system, guys, you're giving this guy to LTI system, it is very elegant, right? You will get complex exponential only. Okay, this complex exponential, if you're applying complex exponential, so you will get complex exponential only, right? Okay, this is very important. Okay, so you will get complex exponential only, provided there will be some multiplication by k, you can say, right? So k times the exponential, complex exponential, right? Okay, where this k will be known as eigenvalue. Okay, and this complex exponential will be known as eigenfunction. Okay, so if you are applying complex exponential to LTI system, what kind of output you will get? You will get always as eigenvalue times the complex exponential, right? If you're applying sinusoidal to the LTI system, you will get always output as sinusoidal, a sine only, same frequency, provided its amplitude might change as well as the phase. ठीक है, ये आपको याद रखना है, ये एक आइगन फंक्शन, इट्स अ प्रॉपर्टी ऑफ आइगन फंक्शन. Complex exponential if you are applying, or in case of complex exponential, there will be sine theta, cos theta, sine term, cos term. Okay, so you have to remember these points. ठीक है, so suppose any signal phi t is there. Suppose phi t is there, right? Suppose you have got phi t. Okay? So you want to write xt as linear combination of this phi t. You can say phi it is a basic signal we have. Basic signal. So we can write this any arbitrary signal xt as linear combination of basic signal. You can say it will be a1 phi 1t plus a2 phi 2t plus a3 phi 3t, right, and so on. Okay, you can say -1 minus, you can also go like in the negative direction as. Okay, I think this is fine. So what we can say, suppose this is phi kt, right? Okay, so what we are doing, we are multiplying with some scalar constant and then we are writing as a linear combination. So we can combine. You suppose this phi kt is nothing but e raised to power j k omega naught t. Suppose this is your phi kt, right? The basic signal is what? Complex exponential. तो मैंने आपको बताया ना, अगर आप basic signal complex exponential लेते हो तो you have to go for Fourier analysis. You have to go for Fourier analysis. Like you have to talk about Fourier series, right? तब देखो यहाँ पर क्या होगा, इसको मैं लिखता हूँ यहाँ पर, देखो xt is going to be equal to a1 e raised to power j omega naught t plus a2 e raised to power j 2 omega naught t plus a3 e raised to power j 3 omega naught t and so on. ये both side you can say, both side. since it is a exponential signal, so k can be -1, -2, -3, 0, everything, right? So this can be written as a linear combination, you see. So what we can say here is that we will write here xt as ak times e raised to power jk omega naught t, and sum over k going from -infinity to infinity. And what is this, guys? What is this? You are able to synthesize the xt. You are able to get the xt from लीनियर कॉम्बिनेशन ऑफ कॉम्प्लेक्स एक्सपोनेंशियल. अब आप देख सकते हो यहाँ पर कि आप xt को डिजाइन कर सकते हो. यू आर एबल टू कंस्ट्रक्ट xt. आप कोई भी आर्बिट्ररी सिग्नल को एज अ लीनियर कॉम्बिनेशन ऑफ एक्सपोनेंशियल्स लिख सकते हो. इसको हम लोग क्या बोलते हैं? दिस इज नथिंग बट अ कॉम्प्लेक्स एक्सपोनेंशियल फोरियर सीरीज. इट इज नथिंग बट अ कॉम्प्लेक्स exponential Fourier series, right? And this AK is known as exponential Fourier series coefficient. Okay. This k omega naught is nothing but the multiple of fundamental frequency. There are many frequencies: omega naught, 2 omega naught, 3 omega naught, 5. Okay, I think this is fine, right? So it is nothing but linear combination of. अब देखो यहां पर क्या है. As I said, spectrum Fourier series discrete in frequency, right? So we will consider discrete frequency here, right? So we are going to choose here the summation. ठीक है, याद रखना. Linear combination of, अगर discrete frequencies हैं तो combination of exponential e raised to power j omega naught t. We call this guy as, this equation as synthesis equation. इसको क्या बोलते हैं? Synthesis equation of Fourier series. Why we call it synthesis equation of Fourier series, guys? Because we are able to synthesize the xt. Synthesis का मतलब होता है क्या करना? Synthesis का मतलब क्या होता है? जैसे मान लो you have to build a home, right? Input is given, डिजाइन इज गिवन. ठीक है, आपको इंजीनियर ने डिजाइन बना के दे दिया है. यू आर गिविंग इनपुट एज वेल. नाउ यू हैव टू गेट द सर्किट. ठीक है, so there are two things that you have to always keep in mind. एक होता है एनालिसिस, एक होता है सिंथेसिस. And two kind of questions also asked in the gate examination: synthesis based question, analysis. Synthesis का मतलब ये होता है कि suppose system is there, input is there, so you have to find output. And this kind of questions most of the time they ask, right? Like suppose circuit is given, input is given, they will find what will be the voltage across resistance, what will be the current through that resistance, right? So this is known as analysis. Agar these two guys are given, input is given, system is given. System you can say is circuit, whatever, right? And you have to find this. So this is called analysis. And synthesis का मतलब होता है input is given, output is also known. Okay? See, I am giving you the input, I am teaching you. ठीक है, you know the output also. You have to get into ISC Bangalore, ठीक है, और IIT Bombay. What you have to build a system. अपने माइंड में आपके अपने माइंड को बनाना है, right? So you have to plan accordingly, right? So these two guys are given, so you have to design it. Then this is known as synthesis. But okay, so we will meet later, guys. I don't want to make the session very long. To cut the story short, this is the basics. I will continue my basic again, right? This is the introduction, right? I will continue the basics. We'll meet shortly, right? We'll talk about Fourier transform, okay, properties, okay, what are the properties which are going to play very important role in communication system, right? Okay, take care, thank you, and keep enjoying.